Wilkinson, Gaio, David Attenborough, the documentaries. Wow, this is so much gratitude. You really are doing so much. This is great to see so many answers here. The Fossil Fuel Non-Proliferation Treaty, Just Stop Oil, Paris Agreement, and a more serious debates. The Inflation Reduction Act here in the United States that was passed last year. Not grateful for Ukraine, but it showed Europe's dependency on oil and gas and created urgency. The shift in energy policies that contributed to the forecasting. Ministry for the Future, an amazing book that you could go read, Robeson. Oh, thank you to Climate Interactive, to our 12-person nonprofit here in the US. Christian Climate Action, Greenpeace. Okay, so much gratitude, so much gratitude. All right, let's shift now to the other side of it. This is the good news. Here's the good news, right? The good news is they predict this peak with policies in place, but also strengthening. And I'll note, why is that coal? See the brown line of coal predicted to go down? And I've looked enough at the model and the assumptions behind it. One of the biggest reasons is they're assuming that a carbon price in China will increase. There's 30% of global fossil fuel emissions, CO2 emissions, come from China right now. And most of the growth in coal is in China. STEP's scenario here in the IEA predicts that we'll see rising carbon prices in China through 2050, all the way up to over $50 a ton. That's one of the things that's leading to this, besides the clean energy revolution. So there's the good news. The bad news is a flattening of emissions is insufficient, as we can explore in a minute, to get us where we really need to go. How are we going to get that kind of gray line and red line of oil shifted down? I pulled the title of this session from what is coming to a head in Dubai. Our team is going there to COP28, is the international negotiations that are coming up in November, December in Dubai. And one of the conversations is a phase out or phase down of fossil fuels. This headline in Euronews said the fight over fossil fuels heats up. Antonio Guterres recently called out for phasing out of fossil fuels in order to avoid climate catastrophe. And it sets up this often debate that I want to use some of this time and use En-ROADS to address, which is this debate between phasing out, addressing fossil fuels more directly, which we call like addressing the supply of fossil fuels, and then addressing the demand. And the demand for fossil fuels is, of course, the clean energy revolution, doing things that help boost the competition and demand for fossil fuels: wind, solar, electrification, energy efficiency, improving the grid, many of these other things that don't directly confront fossil fuels, but instead boost the clean energy revolution. I have been part of vigorous debates about, well, it's an either or framing of which is the right way to go. And we don't have as much like a definitive answer to say, we can tell you exactly what the truth is. What we have is a powerful tool for engaging people to think about this challenge grounded in the best available science and in really innovative dynamic modeling about this issue. So what I want to do is to spend a little time exploring these two approaches. What are the strengths and weaknesses of the two approaches? And we're going to do that in this world of this baseline that you see right here. So I'm going to tell you a little bit about where things are headed in the En-ROADS baseline. You can see here we have a somewhat more conservative future than the IEA STEP scenario that I just talked about. We don't assume carbon prices increase. We don't assume that countries around the world ban new coal infrastructure. We don't assume that policies get stronger and stronger over time. Instead, we say, what are the current policies today? And we see, if that happens, you can see the brown is coal, staying flattish. And then on top of it is oil and the natural gas. And then this expanding wedge of wind and solar in green, a bigger wedge, bioenergy in orange. And then on top of it, nuclear. And we can, of course, go look at each of those. When you click on here, primary energy demand types is the best place to go look and see any of those individual ones, such as I just was telling you about the great news about renewables. I'm going to pull up view larger. You can see the growth in renewable energy. And this is what is driving out so much coal, oil, and gas. Just imagine the scale. We've seen over this last 12 years, from 2000 to 2022, this much growth between what, 11 and 31. So it's like 20 exajoules a year of additions. But between 30 and almost 400, so adding 370 and 33, it's like a 10 times growth over time in our baseline. So much more wind and solar. And that is one reason that we see the lack of growth and the peaking of fossil fuels, coal, oil, and gas. Okay, if this is where we get our energy, and if we bring in and include more methane emissions, methane matters so much. Methane from energy production in blue, agriculture in yellow, waste, landfills, and wastewater here in brown. And if we have other gases such as nitrous oxide and F gases, so we add in and model individually all of these other gases, that gets us this graph of all the pollutants that are causing climate change. Right there's the little COVID blip, leveling over time. If that's the case, then we're headed towards 3.3, which is in the range of what scientists think current policies will get us, but a little bit on the high end, because we are here not as a forecast, but a reasonable starting point for model experimentation. I can show you later more of our confidence building about how we test against other simulations, but I really want to get to the meat of this issue. So what I'd like to do is I'm going to create here first, what if we just focused on the clean energy revolution? What if we just boosted and encouraged clean energy and addressed agriculture and other gases? Is that enough? And then we're going to encourage just work on the supply and see what its strengths and weaknesses are. So you'll see we'll be able to test things like renewables down here and energy efficiency, electrification. But what I want to do is get your push about, if we did this, which policies to focus on. What should I click here to make a reasonable scenario that encourages the clean energy revolution, plus agriculture, forestry, actions in nature-based solutions? So please go into the poll, and this is going to end. Someone just click coal. What I'd like to do is stay away from things that directly address coal, oil, and gas. This is a thought experiment. What if we just focused on clean? There it is, like renewables. Now, carbon pricing, you might argue, directly confronts energy efficiency. I'm not asking you, what do you want? I'm asking you, could you construct with me a thought experiment of, we don't do things that discourage, so don't propose things that discourage fossil fuels. Instead, do things that boost the clean energy revolution, energy efficiency, electrification, buildings and industry, renewables. Those are many of the keys. Maybe new zero carbon energy. Great. Okay, I'm going to try many of these things. So here we go over here. So what I need to do with your suggestions is start and let's just take us that the global methane pledge, for example, and other actions to reduce deforestation, do happen and do help. And watch, it's really remarkable what action in methane. Look at these reductions here. When we decrease methane emissions, cutting deforestation is another 0.1, more than 0.1 degrees. So we can see already some of these actions in cutting methane and deforestation get us to this 1.9. So I'm actually going to check this. We're going to call this minus 75 so that we make sure that we are clear about that. And here, well, it's easy to remember, minus 75% and minus 7.5% decrease in deforestation. Okay, so we're going to test just the clean energy revolution and see what it does and how it helps. We're also going to do it in context of this goal of meeting the pledges. And the red dot there are if all the nations of the world follow the NDCs, which are the pledges to the Paris Agreement. Okay, now what if we also encourage renewables? And so here we go, a boost to renewables. And we already, let's see, here we are with, let's go look and see, what if we have more? We're already getting a little bit more. It's interesting, one reason, why are we getting more renewables in En-ROADS? We decrease future temperature. There's less environmental damages because of this. Economic growth is a little higher. Energy demand is a little higher. Therefore, more wind and solar. That's why. That's a feedback loop that we're seeing right here in the model. What if we have even more renewables, a good bit more, and soon? Someone also said, what if we have a breakthrough in, actually, let's just go back here. Here we are with renewables. What if we also have a breakthrough in new zero carbon energy? We can see some of that helping. So boosting renewable energy. And then also, if we're boosting electrification. And here, I'm going to really focus on the parts of the electrification, which is encouraging the clean energy revolution. What if we subsidize electric transport? And what if we build charging infrastructure to meet demand? Look at the bottom right, and we can see the kinds of scenarios the International Energy Agency thinks is possible when it comes to electric share of new demand. We have a dream made, there's air and water electrification that we're not going to count on yet. In buildings and industry, heat pumps and other electrified buildings and industry technologies. So what if we have electric equipment subsidies like heat pumps, et cetera, and we can see, and I'll pull up the graphs, we're going to have more renewable and less, more electricity and therefore more wind and solar. These are some of the things that are cutting back on coal, oil, and gas. And in particular, because of the electrified transport, this is something that if we look at the oil, we now have a real peaking of oil and then a drop over time. In the long term, though, how do we get that oil down even more with the clean energy revolution? It is about electrification, but it's also about continuing to boost the efficiency of transport systems. This is not just vehicles. This is also public transportation, urban design. This is what I got to do in London last week, getting around town on a bicycle or an electric scooter. And also energy efficiency in buildings and industry will be one of the things that can tip things down on coal and gas. Okay, if we took many of these actions, notice now what we've done is we've imagined nature-based solutions, agriculture, forestry, but also boosting the competition to coal, oil, and gas. This is what I'm calling the bottom of those scissors. And by the way, I heard this analogy. I didn't come up with this analogy. I really hope somebody can had also heard this. And I think I read it on Twitter. Does anybody know? Please write in if someone who originated this idea of scissors, of two sides, of how we phase down and phase out fossil fuels directly and indirectly. So I'm seriously asking, who came up with this analogy? We're building up this encourage clean energy, the bottom part of the scissors. Here is a scenario in En-ROADS that you, for yourself or engaging other people, and that's how we like to do this. And what I've done with many groups, foundations, with, frankly, in the finance world, with bankers, with public officials, let's just imagine the clean energy revolution. And I'm going to actually share this with you. I'm going to copy the scenario link. You see that in the corner, and go to chat. And I'm going to let you go look at it yourself. And it was done kind of quickly, but it's a pretty good sense of how we think of just approaching the clean energy boost, the clean energy revolution side. Now, what do you see? What I see in particular is it is slow. It is slow. Even if we push all these policies, and these policies start today, it takes time to get rid of the old internal combustion engines and bring in the electrified vehicles. It takes time to get rid of the coal, oil, and gas infrastructure as it slowly retires away and bring in the new zero carbon energy sources. This is what we call capital stock turnover delays. In the energy supply world, those delays, that equipment that we're investing in, the infrastructure, lasts 30 years. It takes a long time to retire it away. Demand infrastructure, such as vehicles and transportation systems, last 10 or 15 years, buildings a little longer. If we wait for old stuff to retire out and come in, it just takes time. Now, it's powerful, and we're really thrilled about what it's bringing. But do you see when we really get those emissions falling? It's out in these 2040s, 2050s, 2060s. See that red dot? The red dot is all the countries of the world. If we follow the NDCs, we have pledged to bring this blue line through the dot. Now, it is powerful. We appreciate it. So the challenge is it's slow. Slower than we would like to meet climate goals. The benefit is that it is helpful to one of the biggest equity challenges that there is in the world today, and that is the cost of energy. Notice the blue line, that if we're able to reduce demand, that energy prices are actually lower. We're investing in renewable energy, which is the cheapest supply. We're reducing demand, which, just because of basic economics, brings that cost down. Now, people in marginalized communities disproportionately pay more for their energy. It is not fair for those costs to go up. So this is what's really wonderful about the approach of encouraging the clean energy revolution. So it brings costs down. That's good. It is slower than we would like. Therefore, because time really matters, we need to get emissions down soon. It's bringing that temperature down to what many imagine to be where things could be headed, 2.3, if that's all we focus on. So we can see how far it gets us, but a bit of the limit of its contribution and its insufficiency. So I'm going to just pause this one. I'm going to keep this scenario alive here. And I'm actually going to go get another one. And we're going to open another version of En-ROADS. If you want En-ROADS, go to Climate Interactive, En-ROADS, and then boom, here it is. Open another one. So now let's imagine the other side. Let's imagine and create, what if we just focus on the supply side? And as we think of it, I want you, and I'm going to do another poll. I just wrote down a list of all of the various things that are being discussed when it comes to discouraging fossil fuels, or in the case of subsidies, encouraging them less. and we'll pull up the data. We subsidize fossil fuels today. So one answer here is not just going out and saying stop fossil fuels. It is for countries to not subsidize. And that is, I have it in here as A. It is the answer A, if you think that's the highest priority. So go to the poll. What do you think are the highest priority policies to address it directly? This is the other side of the scissors. Which do you really think we should focus on? Most right now, carbon pricing is winning. Reducing fossil fuel subsidies is also high. Banning exploration and drilling. This is what the Biden administration here in the US has been encouraged to do. Sometimes it's doing it, sometimes it hasn't. Building code to restrict infrastructure. Someone mentioned Jay Inslee, and he had been advocating in many states, let's not build natural gas infrastructure going into new buildings. For E, 2030, 2035, different France and California have said we're not going to have internal combustion engine vehicles, which use oil, gasoline, of course, or petroleum. Counter fossil fuel infrastructure locally. My colleague Kelly Sheehan was telling me about in Los Angeles, trying to stop oil drilling in the city where people, particularly in marginalized communities, have been facing the challenge of oil wells near their homes, divestment from oil and gas, international treaties. In Dubai, they're talking about it. Stop oil, and that would be the phase out and phase down of unabated fossil fuels. Stop oil and gas pipelines and infrastructure. This is the work of 350.org, Bill McKibben, Keystone XL pipelines addressed I. Okay, what were your votes? Subsidies, carbon pricing, divestment was where you were policy. So great, thank you. So I'm going to go here to this one. Now what we're going to do is I'm going to recreate the same scenario. And here, what did we say? We said we were going to have a minus 75 with methane. And we were going to have here, we were going to have minus, I think, 7.5. Okay, so we do the same amount of things in forestry and in methane in agriculture, but we're not going to focus as much. Now, of course, this is a thought experiment. This is not what is being proposed, but I want us to just do a thought experiment to see the other side of this question. So what got votes? Divestment. In En-ROADS, divestment increases the cost of oil and gas, and it could be captured equivalent to a tax. So that's imperfect, but it will do the same kind of thing that I really want. And we'll look here. I'm going to look at natural gas. And here, if we have less natural gas, divestment, that would be very high, and in oil. And frankly, I think I'm going to give us the whole, here you can have overall just reducing coal infrastructure. The IEA thinks it's happening anyways. Much of it is happening. So what if we have reducing coal infrastructure, the kinds of scenarios that they think are likely coming? So what if we're able to address coal more directly like this, divest oil and gas, and encourage carbon pricing? The kind of numbers that the scenarios that were put forward in the new zero carbon energy or net zero report. And I think if you would, Clara, could you post the second report from the IEA? They actually did make a scenario where they were like, what it really takes to get down to net zero. And you'll see carbon prices there, 30, 80, even higher than this to get to perhaps $75 a ton around the world. Okay. What I've done is that we're focusing on the supply side. more directly oil, less oil, we peak gas. Now, it's interesting. Why is it going up there? One reason it's going up there is because when we ban coal entirely, some of the demand is going over to natural gas. So you're starting to see why we also need more encouragement of renewable energy to get already. Now, note, if we focus on the supply, we also get the clean energy revolution. We have not encouraged renewables at all. And yet, look how much faster they're growing, because this is a dynamic model. Cutting the supply builds the demand for electricity. Where does the world get new electricity? Here, much of it from wind and solar. Also, though, there's a boost to natural gas. So what we're doing here is we're saying if we just push on the supply side. Now, what is powerful about it? What is powerful about it is look how fast it works. When we have carbon pricing, when we address coal and oil and gas more directly, here this is key. We stop the utilization of existing capacity. We don't just wait for the old stuff to leave. We also are cutting the use of the infrastructure that we have today. Less drilling, less burning of gas and electric generation, less burning of coal and electric generation. We use our existing infrastructure less today. That brings emissions down more quickly. There's some other things that can be done here. We can also, in En-ROADS, encourage or discourage fuel-powered transport sales. So if we have less of that, that helps even more. This is internal combustion engine bans. We can also test no new infrastructure going into buildings and industry for natural gas and other fossil fuels. Fuel-powered equipment sales limit is what we call it. And so that helps a little bit more. Now, this could get us towards 2 degrees if we just work on the supply side. Okay, what are you seeing? We did one scenario, and I'll go back here. Just on this clean energy side, 1/2 of the scissors, 2.3. What was hurting it? It was kind of slow, was a challenge. This acts sooner. However, one of the challenges it faced is, and of course we know this challenge, is cost of energy does the different direction. We know if we tax coal, oil, and gas, if we have a carbon price, it is increasing the cost of energy. It is increasing the cost of energy, and there are equity challenges to this. Our good colleagues at Citizen Climate Lobby talk about dividending some of the revenue back to people as a way to address this, but the problem still remains what to do about this challenge of energy prices going up. And of course, this is one of the reasons that it's been so difficult to pass supply side actions, because of the anticipated increase to energy costs, which is so daunting to our political leaders whom we are asking to think about this. So what is the summary? Work on just clean energy side. A little slower, but helps with this energy cost problem. Work on the supply side, the other side of the scissors. Faster, more direct action. However, boosting some of these costs in a time that we don't want to. So, of course, what do we really need to do? And the answer, of course, and I'm just going to add it into here, this clean energy revolution, is when we supplement clean energy with carbon pricing, with other things that boost or decrease fossil fuel infrastructure, less coal, et cetera, and possibly other actions, carbon removal. There are possibilities that we could explore here, ag soil carbon, maybe some of these actions, et cetera, and maybe a little bit of direct air capture, but probably not These are the kinds of things that get this temperature down all the way towards 1.8 degrees, well below 2 degrees, that get us towards what we're all looking for, which is the net zero, close to net zero emissions in the second half of the century. But overall, what we're seeing is the need for these two things together. And that really is the punchline of this, is that it's a false dichotomy. Of course, we need the two. And any times that you hear that say it's all about one side or the other, I would encourage you not just to assert that it's not the case, but to take people through a similar set of experiments as I just did with you. Let's imagine one or the other, seeing that neither get us well below 2 degrees where we really need to go. Instead, it's helpful to think of it, we think of as the two sides, discouraging fossil fuels, or at least by cutting subsidies, encouraging less. And the other side, encouraging clean energy, the two together bringing the results that we really need, because they could work in consort. And let's not spend the time saying that the other half of the scissors is not as needed. So what I want us, though, to do is to imagine, and I know there's a lot to think about with this idea, and I want to engage you. And when we end this at the top of the hour, we're going to take more questions. But I really want to just pause and spend a minute just with this scenario that we put together on either sides, that you encourage, that you created by clicking your dots and then encouraging on the supply side. If we could actually make something like this happen, if you could really make something like this happen, back to where we were with the gratitude of what brought us today. Think about when you were imagining and the appreciation for others. In a similar way, let's just think about what we would love about a combination of policies here, where it takes many seeds to plant this garden. There are many actions from many different angles that we just simulated. What would you love about being part of a world that was on track to making something like this happen? What would you love about being part of a world on track to making something like this? I'm not saying literally this scenario, and I'm going to pull it up in my phone here, a timer, because I'd really like us to just, this has been very intense. I've been talking at you about some complex modeling and policy issues. Let's just pause 60 seconds. 60 seconds. I'm going to be quiet. What would you love about being part of a world on track to making something like this happen? What would you love? Love to hear what you would love. And I think I have. Please go to the poll. What would you love? Please go to the poll and write. For me, I love the idea of us coming together, global cooperation, and what it could bring for peace, the possibility for peace and democracy to endure, hope for generations to enjoy life, just survival, survival, international cooperation. There's such threats to international cooperation right now with the recent war. Could there be ways that collaboration could help us? Global cooperation, essential challenges can yield results. The feeling there is real hope for the world that your kids are going to inherit. Joy living the garden that is earth. We've taken the first step towards a regenerative future. Don't have to worry about deterioration affecting your children's future. Biodiversity, being part of sharing this knowledge and helping a better world for your child, a more positive outlook toward cooperation and hope for generations. Reduction of anxiety, replacing uncertainty of the what if I had done more with I'm trying effectively. Human resilience through innovation, making hard decisions. Less fear and joy of knowing we have a livable earth, seeing a bright green world, greener environment, clean air, less climate catastrophes. Love knowing that your kids and grandkids can still enjoy living on earth. These are beautiful. Thank you. Love to help people and the world in the future. Fantastic. Fantastic. And our next question, what does this lead you to do? And note, I'm not telling you to change your life right now based on this insight. And I'm curious to see, it could be what you need to think about or get curious about. If there's, love any implications of this point about supply versus demand or supply and demand. What is your next action? But really, that's the bottom line, isn't it? Is what can we do ourselves to address? You're going to finish the En-ROADS Ambassador course. Fantastic. Enroll in En-ROADS instruction. Can you post that again, Clara? Talk more about climate change. Decorate your entire work life to this topic. Finish the course. What else are you going to do next? Enroll in the instruction. So you'll see that you can now watch 63 short videos to engage other people using this event. And holding the seminars engage people using a tool like this. Citizen Climate Lobby, which is advocating for climate pricing, carbon pricing, is an amazing group. And now they have a broader platform than just carbon pricing. Ask your company to offer clean energy investment in your 401k. Fantastic. Introduce En-ROADS to your friends. Help create local models. Then be an ambassador. Share this with others. Great. Continue your education and the understanding of issues. Fantastic. Finish the En-ROADS course in order to make events in the schools and with public administration. You just bought an electric vehicle, working on your landlord to install panels. Great. Keeping hope alive. Continuing your Extinction Rebellion activism. Share these insights with as many people as possible. Fantastic. Doing everything that you've been doing. Your personal commitments to net zero, influence others to do the same. I want to finish with one other little set of slides about the possibility here and the fact that we know what good progress looks like. And in particular, I just want to look to our examples around the world of other times when we face this. Pollutants are going up. We know they need to go down. Again, the International Energy Agency just said we've peaked. How do we get things to go down? Well, here we are, the ozone layer. So this is the concentration of the ozone destroying concentration, stratospheric chlorine. This is the stuff that, if you're as old as me, you remember in the 1980s, we're concerned about the ozone layer. We were watching 1960 to 1990, the pollutants that were up there in the atmosphere, destroying the ozone layer, growing and growing. Well, what happened since 1990? It peaked, and now the concentrations have fallen in different parts of the world. Why? Well, in the case of ozone depleting substances, chlorofluorocarbons, etc. In this case, and this is the case for restricting the supply, we just banned the stuff. It was easier because there were replacements, but here is the consumption of ozone depleting substances. In 1990, it just went down around the world. That is one reason that the concentration, and now, of course, the equivalent here is this is like burning coal, oil, and gas and methane. It just went down. And this is like CO2 in the atmosphere. How many parts per million of carbon dioxide is in the atmosphere? Other examples, results in the United States for the acidity of lakes and streams in the United States. In 1990s, this is the percent of water bodies that are chronically acidic. Acid rain was a motivating challenge that got me into environmental studies classes back in the 1980s. It has gone down. We have really made huge progress. Down, down, down. Acidity is falling in lakes, water bodies in New England and other regions. Why? Because the pollutant went down. Sulfur dioxide emissions. We were able to figure that out with sulfur dioxide scrubbers. We just figured out, legislatively reduce them. Why? Here there's the emissions in short tons, 1990, down, 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 down. We really figured that one out. Let's do another one that's not environmental. Lung cancer deaths, 1950, see the red line, up to 1980, lung cancer deaths had been going up. Cigarette sales since 1900, up, 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 up. Cigarette sales went down since the 1970s, down, down, down. The number of deaths have gone down. It works when you focus on the supply side as well. So, of course, that is the challenge here. Now, I have to admit, looking at these examples of colleagues who've worked on acid rain, lung cancer, the ozone holes, I have to admit, at times I feel like my colleagues and my friends in my class all graduated and everything is going down, and I'm still been working on this issue for 30 years. Still, all of these years, these emissions have been going up. So I want the IEA to be right, and I want the future that we just charted out in En-ROADS. I want this scenario that we just charted out in En-ROADS to happen. I want to see, and the equivalent is the pollutants, emissions going down, and the concentrations, the stuff in the atmosphere, at least peaking and falling over time. That is what we really need in order to keep that temperature that we see here to at least peak and flatten around 1.7, 1.8. Overall, what did we see? There was no one thing. It's not about the supply side or the demand side. It takes both and nature-based solutions in agriculture, forestry, and industry, etc. It takes many seeds to plant this garden, and it's still possible. We want this badly, my friends. It's not going to be easy to make it happen. It's not going to be easy. It's going to be worth it. So go do your part. Go get them. Have a great day. And I will stick around. We'll stick around to answer more of your questions if you want to stay on. Bye-bye. All right. I did say I'd stick around. You can gracefully head out, but I'm here. We're here. And I assume, boy, Clara and Ava have been answering your questions extensively here. I assume you've gone to the Q&A and answered questions there. But I really want to spend a little time. Ava and Clara, are there any? Wow, let me just do a couple live that I see here. What would such a scenario do to the oil and gas lobby, and how can they anticipate to fight against it? What would such a scenario do to the oil and gas lobby, And how can we fight against it? Well, so I want to just go look. Let's go see, what does oil and gas do in these scenarios? As many have analyzed, okay, so in this scenario, oil peaks here in 2026, not in 2030, earlier than IEA, and then falls radically. That's faster than the IEA steps. That's more like the IEA news net zero scenario. And natural gas falls even steeper. This means profits fall. This means there are a large amount of stranded assets. And so the industries that are the largest industries on earth, of course, have huge incentives to fight the policies you see below. We're already seeing it because, of course. And well, that is why a global civil society movement to drive these policies is so needed. And I'm going to look and see, well, it's not quite as harsh in the just the clean energy approach. So I'll just do the same kind of scenario. If here's oil, here's gas, if we just focus on clean energy, electrification, some energy efficiency, those peaks don't happen until the 2030s, and then the decline is much softer. So this is, you can understand why there would be more tolerance of the clean energy revolution. But it's when we start bringing in the things that get us to the lower temperatures like this, well, I'll bring in some of the methane, that we know we can get to lower temperatures with just clean energy. This kind of scenario is going to spark less of a reaction from the oil and gas lobby, I would guess, than this. Do you see that difference between a gentle transition that's more delayed out in the 2030s and then a sooner one? So what can we do? Well, this is civil society power to stand up and say, no, we really want 1.8. We don't want 2.4 because, and I didn't show much about it, but if you're new to En-ROADS, let's just be clear that the reason we want these kind of results, you can see quite clearly in maps of biodiversity improvements. Here's a species losing more than half of their range, not 51%, but only 13 in invertebrates, not 50, but 13 in insects for nature. When it comes to feeding people, crop yield, the fact that if we succeed at getting to 1.8, we don't have a 19% drop in maize crop yield, but only 8. Wheat, not 16, but 6. Rice, not 8%, but 3. And I could go on, right? Heat deaths and other impacts, additional deaths from extreme heat. You get the idea. Okay. So this is about a civil society movement. Clara, were there other questions that you would guide me towards?
But first, Drew, some people are interested in this scenario link. If you can share it in the chat.
Yeah. Oh, thank you. Okay, I'm going to come back. Here's the 1.8. Here's the copy scenario link. Here, go to chat. And here's that 1.8 degree scenario. Are military emissions included in the model? Linda, yes. They are part of transportation. They are part of buildings and industry. They are in the model currently. You're curious? Oh, Garrett, any plans to include geoengineering as part of the model? Solar radiation management. So Garrett, we have this model that is the public online version. We have a mathematical model called that is in Vensim, Ventana's software program, which is where we build the model. And we have experimented with scenarios where we simulate sulfate aerosols in the stratosphere in that model and tested it. And so, yes, we've tested it in our own to explore the dynamics. We haven't included it here because you can't show the costs of doing so sufficiently. So we haven't included it here. Garrett, the unexpected tipping point in the West Antarctic ice sheet is being accounted for in En-ROADS. Thank you. Okay, so many of you saw, and I pulled up this headline. This is the headline I saw. Science Tech Daily, we lost control. West Antarctic ice sheets unavoidable meltdown. So first, before being too glib about it, this is the 60 seconds of silence kind of topic. We should take the time to be forgiving of ourselves in taking in this kind of information. And what we've heard is that there's this paper that says that part of West Antarctic ice sheet, which is, land ice that is outside of the ocean, no matter what, even if we get to an emission scenario like this, is at some point going to increase sea level rise significantly. So first, let's just be with that fact that that's the scientific finding. I know I had a tough moment of feeling quite emotional sitting on my couch at 6 a.m. That's how I handle this. However you handle this, I encourage you to, because facing the truth of this global crisis is critical. If you take our course, you'll see a framework that we offer for thinking about looking at current reality. We call that the bottom of the rubber band. And look at the world that we want to see and notice the gap, and notice that there is our arms get tired when we aim so high, and then we have to look is going to drop in the ocean and significantly increase sea level rise. Be patient with yourself. Okay, you asked about. Let's go check it out. All right. Here is En-ROADS. Here is sea level rise. This is a moment to go look. I'm going to pull up temperature. When you click on this, and you click on any of the triangles, you see what's behind it, and you learn, hey, where did Climate Interactive, which of the many studies did they use? So we calibrated this to these two studies. We tried to find recent studies, and you can go look at Dangendorf et al. Go click on it. And so here is persistent acceleration since the 1960s. This is a paper recently that was published. So this is a little bit about how we calibrate the model. But what that paper said is, hey, we have some new insights that it may be more than we thought. How do we think about it? Here we have been going up sea level rise. Here we are in 2022. Recently, it is at 2023, 0.08 meters, headed towards this point of 0.7-ish by the end of the century. Go to simulation assumptions. We make our assumptions transparent for many of the variables. Sea level rise is right here. And that paper is about the contribution to sea level rise from ice sheet melt in Greenland. And you can see what the description is, the effect of more or less sea level rise, according to AR6, this is the most recent report, this is 0.11 in this one scenario that they call SSP 370. I'm using technical language from that, but you can handle it. And so what it says is that that's what we calibrated to. And there is a high estimate and a full range. So here it says that the high estimate for that scenario is 0.16. So their high estimate, you could go put it in here 0.016 and see, let's imagine a different assumption. And then it's a little bit more. Okay, that's a possibility. Then it says, well, estimates vary from 0 to 0.59 under the full range. And because that news came out, I asked Adem Delabash from our team, and he looked up like the worst case scenario that was modeled by those big general circulation models, and could go all the way up to 0.59. So what we're looking at is, what are the implications over this next 75 years? That's the key distinction. Over the next 75 years, it could go up, they think, to about 0.59 and go faster. So therefore, we would get more sea level rise, okay, if it was 0.59. So it's a question of more in the next, over the next 75 years, in a time horizon that we're modeling and we encourage us to talk about today. The paper was talking about the fact that post 2100, we're likely to see much more. And we've known that if the world is warmer, those land ice does melt. And over the next 75 years, it could warm faster. But I want you to get away from the idea that on a certain day in the next few decades, suddenly sea level rise is going to spring up several meters. Do you notice that's not happening? This is a gradual process. There isn't going to be a doomsday event over the next 75 years that the scientists think is coming. And I actually have talked to people who think that that's what it's about, is a big splash like you see in the doomsday movies. Instead, this could be happening faster. And when you want to go look at it, you can see what are the implications of that. Go look here in sea level rise maps, and you can see what would be the implications of this. And I think what I need to do is I'm going to go here and we could go look, a classic place to go look, say, would be Miami. And you could see what are the implications for an area that, like, say, I know. And you could ask and go look yourself and see what the implications are. And I'm going to go look. So what I'm going to do is do the difference between without the worst case and then with it. So there's without the worst case, and then in 2100, and then with the worst case by 2100, note in 75 years. So did you notice that difference? It was, and I think I can make it bigger. There it is in 2100, and I'm going to go back to where it was before. Note our colleagues at Climate Central gave us this map. So it's a good bit of sea level rise in this area, and then a good bit more. So note, this is not all of South Florida getting flooded or not. Instead, it is an incrementally worse, step worse scenario in that possible future. And I haven't talked this through. I hope that was helpful. Again, I'll come back to the first point is climate change is here. We are coping with it. Otis is hitting Acapulco today, Hurricane Otis. Let's support the people who are the most vulnerable to these impacts. Okay. Garrett said, you noted that you're working on the Greenland meters versus Antarctic. Oh, wait, did I just do Greenland? Claire, did I do Greenland? Let me go back.
Maybe I wasn't paying attention, but yes, apparently.
Oh, shoot. Thank you. Okay, let's do the same thing. That was my mistake. Thank you, Garrett. Okay. Antarctic, my fault. Let's see, is similar, but it only goes to 0.56. So I think it was 0.59 with the other 0.56. So the short answer, Garrett, is no. The same message is true. The same message is true. Let's hope they don't happen together. Okay, that was a long question, but I knew someone was going to ask it, so I wanted to spend some time, and maybe others are thinking about it. Why are the removals in CO2 emissions and removals not removed from CO2 net emissions? Martin. Clara, I might need you to help me do this right. Why are the removals in CO2 emissions and removals not removed? And I'm going to go back. I'm going to undo all of this. Okay, so okay, CO2 emissions and removals, CO2 net emissions. Okay. Why are removals? Okay, so CO2 net emissions is over on the right, is anthropogenic human-based carbon emissions minus the afforestation and any technological carbon removal. So that's net emissions into the atmosphere. And I think it is this red line. So there it is. This is what we're putting into the atmosphere. CO2 removals is not anthropogenic. CO2 removals is what's removed by Earth. Oceans, absorbed into the oceans and into biomass, trees and soils, part of that carbon cycle. So that is not anthropogenic. This is what we're putting in. This is the net of what's going out. And the definition is here: net uptake and net sequestration of CO2 into plant soils and oceans, including afforestation and carbon removal. So when we boost removals here, watch the blue line, we grow. Do you see that the blue line goes up? So we're boosting removals with growing trees. You see that? Boosting removal, growing trees. CO2 net emissions goes down because that's part of the net emissions. You see, we're boosting removals, growing trees. Or when we have technological carbon removal, direct air capture, etc., you see it going up in the same way. So that decreases net emissions because that includes it, and it boosts overall removals on the left. I hope that shows the distinction. I'm confident we're doing the math right. Anything you would add, or does that seem like enough on this one, Clara? Stocks flows in the bathtub video is wrong. No, I sure hope not, because stocks flows in the bathtub, the idea of the bathtub is, well, it's really back here. And for anybody who's interested in it, is that here's the bathtub. This CO2 concentration, CO2 in the atmosphere, is how much water there is in the bathtub. It is the accumulation of all CO2 in the atmosphere. It is increased by the inflows, which is the red line, going into the bathtub every year, gigaton CO2 per year flowing in. It is decreased by net emissions. CO2 emissions and decreased by net removals. Net removals are here, getting pulled out. So we put in double what we pull out. Therefore, this is going up. And the key idea with that bathtub idea and that video is, and if you could send it to folks, Clara, I know we do have the video, and I know it's in Climate Leader. There's a really good video on it. When we watch the things that we do to reduce emissions, they're going to change removals as well. But if we have less coal and oil and gas and carbon price and other things that bring, I'll even do it to here, emissions down. And if we boost removals up, carbon removals, et cetera, the moment they hit each other, you see there in 2045, emissions equals net removals. Concentrations are now flat. What's going into the bathtub equals what's going out. And so the level of water in the bathtub isn't going up or down, it is flat. So that's the main idea there. But we might need to follow up more. You could write into, and when you have a moment like this, you're like, Drew just gave an answer, but that did not answer my question. I still think your video is wrong. The best place to go is here to help support. And if you click on that, first, you'll type in a search word like bathtub, and you'll see, hey, we should have a link there, shouldn't we? We should have something that links to our videos about the bathtub. I guess we don't have something on the bathtub. Okay, so this would be a moment where you would say, hey, I have a question. Dear Climate Interactive, I think your bathtub video is wrong here, and you could submit a ticket. That's how to follow through to get to our support page. So I think I need to move on to some of these other questions. Are greenhouse gas emissions related to electrification mining explicitly accounted in En-ROADS? If not, how do we model them equivalently? Re-emissions. Oh, all the mining that's needed for electrification, not explicitly broken out. It's part of the industry that's going on. We could add that someday, Harold. Thank you, but we haven't. We haven't done it. Martin has gotten ignored. You think the bathtub is right, but not modeled. I hear you. Yeah. Sorry that you got ignored. Clara, maybe you can note that we'll go, the bathtub is right, but not modeled. I really hope it. I'm guessing that there's a definitions problem here of what we mean by net. Okay. The social cost of carbon. I'll note, Hannah, if you're curious about the social cost of carbon and you haven't found it yet, please know that you can go in here and look at the social cost of carbon. GDP. So you can use En-ROADS to calculate your own social cost of carbon to anyone interested in this. This is, what does it cost the world to emit carbon dioxide given climate damages? We have various assumptions about climate damages. That is, as temperature goes up to 2, 3, 4, 5 degrees, how much does GDP go down? And allows you to pick whatever damage function, we call it, you want. Burke 2015, Dietz and Stern, or Burke 2018, and a social discount rate, because economists don't value the future as much as today. And so you could calculate, you said $220. Well, I don't know, maybe that is $300 per we'll just keep it at 3. So here we're count if the social discount rate is 3, if Burke et al. 2018 is the damage function, and if emissions are headed to 3.3, then the cost of carbon is $391 a ton, and the discounted cumulative damage is that much. These are things that you could explore if you're really curious about it. Okay. And others that, boy, I'm just opening the chat for the first time, and maybe we're done, Clara and Ava. Maybe we're done